The contraption starts here at the top of the structure, and when I hit the button on the remote control here, it will lift the flap, which lets the ball fall down. And the ball will fall down this here. It will fall through a hole in the bottom of the board and go down a pipe, which will start a pneumatic motor, allow a ball to fall down here, which will lift up some baking soda cubes into some water. And then the pinball machine robot proceeds to go, and this is where the computer comes in. We'll play a little pinball here. A little better view on how the pinball machine works from over here. It will lift up, turn. This is the left-right motion of the robot is controlled by a stepper motor. As the ball falls, it breaks an infrared beam right in front of the flappers, which signals the flappers to start, which you'll see here in a second. There, it breaks the infrared beam as the ball runs right in front of the flappers, and the flappers sit them back out. And when it loses, the ball falls into the tray and back into the robot. After the pinball machine is done playing, then we go on to the book. And the object of this competition was to put a bookmark in a book on page 15 and then shut the book. Instead of starting out on page 15, we've opted to start out on page 1 and turn to page 15, and this is the way that we do it. The dustbuster turns on, and that creates a vacuum, and the dustbuster lifts up by a stepper motor attached onto the back of the handle of it. And then the train on the right side of this picture here goes forward, flips the page over, then reverses to the back in its position. This is all controlled by the computer. Okay, you've got a few eyes there, read the book. Train comes forward and reverses. You can see the stepper motor that controls the sweeper on the right side of this picture here. There, the bookmark's put into the book. Okay, now the book is shutting. And the way that's done is there's a string attached to the back of the sweeper, and the computer slowly lifts the sweeper up. And as the sweeper lifts up, it's got a string attached to a rod which is sitting against the back of the book, and it slowly goes to shut the book. And the book's shut. I designed all the electronics on this except for the remote control that started the project, and that remote control I modified from a defective car alarm. I designed everything from the power supply to the interface controller. This is the power supply here, and I designed it, and then the interface controller is over here. I've nicknamed the interface controller Hiccup for High-Speed Interface Controller Universally Programmed, and its basic function is to decode address bits from the computer. It hooks onto the bus of the computer, which means that basically that it's connected directly to the CPU. The CPU sends out 19 bits of address, and it decodes the top 12 bits of that address. When the computer writes to its address, it latches 8 bits of data to this board here, which is the board that connects the computer to the outside circuits here. This board will switch 16 bits of output or 8 bits of input. The project starts over here with the first input on this dump truck here, raises up and drops a piece of baking soda into the water here. When the baking soda hits the water, it ionizes the distilled water, and allows the current to flow. A LM741 op amp chip detects that flow, and when it detects the voltage, it then signals the computer to start the pinball machine. The pinball machine uses an output to lift up like this, and it also uses an output for the stepper motor, which turns it side to side like this. The stepper motor is a 1.8 degree stepper motor, which means that I can control this robot within 1.8 degrees anywhere within its revolution. The robot goes over, uses another output to dump the ball into the pinball machine, and then it comes back and falls back down into its position. The computer knows when the robot is in the proper position by an infrared beam here, and when the robot comes down, it breaks that beam, and the computer stops the robot and knows that it's set for the ball to come back into it. There's another infrared beam which feeds into an input here, and when the ball comes down here, it breaks that beam, and the flappers will fire at that point, knocking the ball back out. If the flappers miss, the ball falls through. The ball is ejected here, like this, and when this pulls forward here, it lets off of a switch back here, which signals the computer to start the robot again to lift up and go over and up. The computer keeps track of how many times the ball is lost, and after 3 lost balls, we go on to the page turner. The page turner, the sweeper is controlled by a stepper motor right back here. This is also a 1.8 degree stepper motor, and it lifts the sweeper up and lets it down. It's totally computer controlled. The sweeper goes up and down. When the sweeper lifts up, then the train here moves forward, and the train is controlled by a computer as well. It moves forward for a certain time, about 1.5 seconds or so, and then it reverses back. And you might notice that as it reverses back, it kind of lunges. It kind of stops and goes to reduce its speed so that when it hits the backstop here, it doesn't bounce off and jump off the track. That, once again, is all controlled by the computer. And the computer keeps track of how many pages it has turned. And once it gets to page 15, then this here shoots forward and pops the bookmark out in the book. At that point, the computer once again turns the stepper motor on back here and lifts the sweeper up, and the sweeper has a string here attached which goes down here into a rod right back here, which lifts up, and as the sweeper lifts up, the book closes. And when the sweeper gets down far enough, the book will close. I have spent literally hundreds of hours wiring this. I've wired hundreds of data lines into the computer and out of the computer, and I've done a lot of soldering and a lot of work on this. I didn't build any of this from kits. I didn't get any of the circuits out of books. I designed it all on my own, and I've gotten a few ideas from data books and so on, but I've basically done all this on my own. And thank you very much.